All right, in this video, we are not quite done with the normal distribution yet. We're going to look at another application of the normal distribution, and specifically we're going to be talking about how to solve normal distributions problems given a percentage, or it could be an area as well. And we're going to use something called the inverse norm or INV norm function on your calculator. So make sure you've got that nearby because you will need it for this assignment and this video as well. So what are we going to try to answer? Well, a question like this says, suppose the time to complete a test is normally distributed with a mean of 40 minutes and a standard deviation of 5 minutes. So on average, it takes a student 40 minutes to complete this test, standard deviation of 5 minutes. Approximately how long will it take 60% of the class to finish? Okay, so you might be thinking, what is different about this problem than all of the problems we've seen thus far in this chapter? Well, all of the problems we've seen thus far give you a value, right? They'll say it'll ask you what percentage will take longer than 50 minutes, for example. Right, so we were always trying to find a percentage or a decimal value to represent that percentage. So we were always given an X value, if you will, and we're asked to find the percentage. So now we're going to kind of work in reverse. So think of sort of the inverse, right? We're given a percentage and then we're asked to find a specific value. So in this case, how long? That's going to be the value we find given the percentage. Okay, another question here would be, after how many minutes, so we're looking for a specific value, can the teacher expect all but 3% of the test to be completed? So again, the big thing here is that we're given a percentage. Now, how we're going to do this, I've got a slide here, but I actually got a couple of jokes here for you, some more jokes, to show the importance of the normal curve. As I did mention when we started this chapter, that this is probably the most important thing that we'll learn this year is the normal curve. So here's a couple little funny jokes, if you will. And this one, guy's strategy is to shoot for the top of the normal curve, which if you didn't know anything about the normal curve, you might think that's kind of logical, right? However, you guys know that that's the middle. The top percentage would actually be way down here. Same with this one. We got a CEO here sitting there in the top 1%. Well, that means they're very mediocre because the top 1% would be way down here. All right, so I found this little resource here. It's the calculator instructions on how to use the inverse norm command, which is what we're going to be using. All right, so we're going to just walk through here. The inverse norm command is used when you're given a probability or a percentage, and we're asked to find an X value. So that's how you know when you're going to use this. Obviously, in this lesson here, you're always going to be using it, but if you weren't necessarily told that, you would have to know how to determine when you're going to use it. So we use this when we're given a percentage and we want to find an X value. Now, when you do this, you need to enter in an area. And when we enter in the area, it has to be the area to the left. So if you remember, like in the table values, if we wanted just the table value, we did the area to the left versus the area to the right would be 1 minus the table value. Kind of have to do a little manipulation on some of these to make sure that whatever we type in represents the area to the left of the value. Okay, so go ahead and grab out your calculator, and you're going to do this first step here. I want you to hit second and then vars. That's our distribution. And you'll see down there, number 3 is the inverse norm. So go ahead and press enter. And then we're going to answer a question using this function. You'll see we need 3 things to type in. We need an area, a mean, and a standard deviation. So if we're asked to find the question, the IQ score that corresponds to the 95th percentile of IQs, let's go ahead and draw a little sketch and label it. So the top 95% would mean that, well, all of this, that would be like 0.95 area there. That would represent 95%. You can see it here. You don't have to sketch all of these, but nonetheless. And then there would be 0.05 here, meaning if you're in the 95th percentile, you're better than 95% of people, or smarter, I guess, in this case with IQ. And then 5% of people would be smarter or have a higher IQ than you. All right, so the area to the left is not 5%, right? It's 95%. So what we're going to do when we type this in the inverse norm is we always type in the area to the left is our area, right? And then our sigma and our standard deviation. Sorry about the bell. All right, so our area, which we're going to type in, we're going to do n of norm, our area of 0.95. Type in our sigma. Now with IQ scores, we had an example like this earlier in the year. The average IQ score is 100, so that's why you see 100 there. And the standard deviation of IQ scores is 15. So all you're going to do is just type those in. Simple as that. And we get 124.67. So if you're going to be in the top 95 percentile of IQs, meaning your IQ is 95% higher than everybody else, that means your IQ would be at least 124. So it's really high. Right? The top 5%, if you will, people will have an IQ above 124. So pretty high. All right. And it says your calculator will return the X value or the Z score. In our situations, it will always be the X value. If you're looking for a Z score, then Z score would have to have a mean of 0, standard deviation of 1. So there's a way you can do that, but we're just going to concern ourselves with the X value there. All right, so let's go ahead and look at another example. So this time we want to find the IQ score separating the top 15%. So meaning if we were to draw this out, and we want the top 15%, that's what we're looking for up there. However, we don't type in 0.15. We have to type in the area to the left, right? So we need to type in this area, which you have to do 1 minus 0.15. So we actually are going to type in 0.85 for our area, because it tells us area to the right, meaning the top 15% would be the farthest right, 15%. So we want to type in the area to the left, which is 0.85. So your area is just going to change that to 0.85. And your mean and your standard deviation will be the same. So go ahead and do that. Inverse norm, 0.85. Keep your sigma and standard deviation. And we get 115.54. So if your IQ score is above 115, well, you're in the top 15%, or the 85th percentile, the top 15%. I know that wording's a little bit confusing, but there we go. All right, now let's take a look at that example that we talked about earlier. So suppose the time to complete a test is normally distributed, 40 minutes, and standard deviation of 5. Approximately how long will it take 60% of the class to finish? So maybe the teacher is giving a test. They want to make sure that there's enough time in the period that all students or almost all students can pass or finish the test. So first question they want to know is, well, how long is it going to take, like 60%? So more than half, how long is it going to take them? All right, so we're given a percentage. That's going to turn into our area. So all we do is n of norm, type in our area of 0.60. Just make sure you're doing a decimal. It should always be a decimal. If you type in a whole number, I think it'll give you an error. So it should always be a decimal. And then we just type in our mean of 40 and our sigma of 5. And that's really all there is to it. You'll find these problems are easy. The only difficult thing can be interpreting it sometimes, whether you want to do 1 minus the value or not. But other than that, these are quite easy. And then always just make sure your answer makes sense. All right, so if the mean is 40 minutes, it would make sense that 60% would be done in 41 minutes, right? That makes sense, so seems reasonable. All right, and one other question here. After how many minutes can the teacher expect all but about 3% to be completed? Okay, so the way this one is worded, all but 3%, that means this 3% out here would not be completed, right? So we actually want everything else. We want the 97%. So we want 0.97. We want 97% to be completed. So that's going to be our area there. So we're going to type in 0.97, not 0.03. So this one, again, our area is just going to be 0.97 because we want no area to the left. 3% and above would be area to the right. keep our sigma and our our mean and standard deviation. So I'm going to do is change that to 0.97, keep the rest, and that is 49.4 minutes. So let's say the period is 50 minutes. Teacher wants to make sure there's enough time for everyone or almost everyone. Well, she could expect, or he could expect 97% of the students to finish in 49 minutes. So depending on whatever the teacher decides, he or she could decide to maybe eliminate a question from the test if they want to make sure everyone finishes, or if that's cutting it a little too close, maybe eliminate the problem or keep it the same and just have that student or students make it up later. Let's look at another one. Computer World knows that the average life of a laptop computer is normally distributed. The mean is 3 years and the standard deviation is 2 months. Unfortunately, they made a warranty plan in which 40% of the computers sold were returned because they died. Approximately how long was this warranty good for? All right, so someone made a bad decision. They made up a warranty plan for this many months, and it turns out that wasn't good. They made it for too long because 40% of the computers that they sold were brought back because they died, and then so they probably didn't make a lot of money off these computers. So let's figure out, well, how long was that warranty good for? One thing before we move on is notice, I don't know if you caught it, is that there's different units here, 3 years and 2 months. So when we do this, we have to have the same units because you can't compare things of different units. So what I would do is actually just go ahead and convert this to months, that 36 months. I wouldn't change the other one to years because then you would have 2 out of 12 or 1/6 of a year, which, yeah, it's easier to work with whole numbers. So just change that one to months. There is a problem on your assignment where you have to make a change in the units. Always just double check those. So from there, we want to do our inverse norm. Our area, let's think, so 40% died, so that's going to be 0.40, meaning here, so it'd be like 40% died, 40% didn't make it. All right, and then our mean is 36 months, right? Not 3, 36. Sigma is 2. Let's go ahead and type that in. All right, and we got 35.49 months. So that means they probably made the warranty for, I don't know, 35 up to, you can maybe even round to 36 months. But so approximately 40% of people would bring back their computers if the warranty said it was good for 35.5 months, basically. So what they've decided to do now is, well, that's too much. We're not going to make a profit if 40% of people bring their computers back. So we want to lower that warranty a little bit. So we want to improve it, and they don't want to have to replace any more than 10% of computers. 10% is the max. They only want 10% of them to die because else they're not going to make any money. But they also want the warranty to be long so they can, it looks good when customers buy it. They feel reassured that I got a long warranty. But at the same time, the company can't be replacing everybody's computer. So they only want to replace no more than 10%. So it's actually pretty much the same. We just want our 10% that we're going to replace down here. So we don't need to do any subtraction or anything. So we just want that to be now 10% that we're replacing. In other words, we want 10% to last less than the mean. So we're still going to do our inverse norm. Our area is going to be 0.10. Our mean is going to be 36, and our sigma is 2. All right. And with that, we get 33.3443. All right. So what they probably would want to change this is, I would recommend they want to change probably to 33-month warranty. Or if they want to be extra safe, say a 32-month warranty. But if they have it up at 35 or 36, they're going to end up replacing a lot more computers, 30% more computers. So definitely want to keep the warranty a little bit lower so they're not going bankrupt. Now, let's say you made a mistake. So this is going to be wrong, but I just want to show you. let's say you thought that on the second one that the area was supposed to be 0.9. Say you thought you were supposed to subtract it. So if we actually did that, change it to 0.9, our answer then becomes 38.56. And if we were to look at the context of that problem, this would say that they would want to raise the warranty to 38 months. Well, that would be bad because that means they would end up replacing even more. So always look at the context of the problem if you're not sure whether you should do like 1 minus the value or not. Always look at the context of the problem. This can't be correct because that means they would increase their warranty to 38.5 months, where they had to replace 40% of them with only a 35-month warranty. So no way would they want to increase that to 38 months. They want to reduce it to 33 months, so they're only replacing at most 10% of the laptops. So hopefully that made sense. I'm just going to pull up your homework assignment here. You have a bunch of just B problems and B's and D's and stuff. All these are word problems, and you're just going to be doing the ones where it says inverse norm distribution. So like for this first one, you just have to look up in the original problem for the mean. So this one has a mean of 45, standard deviation of 8. And this one, they don't want to make refunds for more than 10%. So actually very similar to what we just did. So that's going to be like your 0.1 as your area. So in all of these, it's just going to be these ones where it says inverse normal distribution. So this one would be the same. You just got your average life up here as your mean, standard deviation, and then that's your value. Just be careful on a couple of them. If, let's see, I don't want to replace 5. So most of these are going to be very similar to the last one we just did. There is one, I think, where they changed the units on you, so be careful with that. See the one, undernourished kittens. All right. Well, anyhow, I think you'll find it. I'll put a note. I'm pretty sure there's one where you have to convert the units, and I'll make a note on that on your homework. So very similar. You're just going to be doing these inverse normal ones. Here it is. All right, 37. Notice how it gives you the average is 3 hours and 48 minutes, and the standard deviation is 52 minutes. So you are going to want to convert this mean to all minutes. You can't leave it as hours and minutes. You need to convert that to all minutes. So make sure you do that. All right, so good luck on those problems, and as always, let me know if you have questions.